How we doing today, guys? It's Mr. Novak. For today's lesson, you guys are going to be learning about acceleration. What I want you to do is take some notes, and we'll copy those into your notebook, onto your worksheet, and let's just get started. All right. So for acceleration, before we get into like what acceleration is, it's kind of important to know kind of the background in terms of what velocity is. So what we worked on in class, we've kind of talked about speed, right, which is distance divided by time. So when we had distance divided by time, we would say like 65 miles per hour, right? So 65 miles would be our distance, hour would be our time, right? So that would be our speed. So the thing we want to learn about is velocity, okay? So speed in a given direction is called velocity, okay? So the only thing that that's gonna be different with velocity is we add a direction. So if we take a look at our compass here, we can see that the direction can be north, it can be south, it can be east, and it can be west. So if we look at our example where it says a car is moving at 55 miles per hour west. So if we look at 55 miles, right, that's our distance. Per hour would be our time. So very similar, right? That's speed. So 55 miles per hour would be our speed. And the last thing we're going to add to it, which makes it velocity, is the direction. So the direction would be west. So 55 miles per hour, speed, right? Direction west, that makes it our velocity. So our velocity would be 55 miles per hour west. So if we look at our definition of acceleration, acceleration is the rate at which velocity changes. So in science, acceleration refers to increasing speed, decreasing speed, or changing direction. So anytime the speed of an object changes, the object experiences acceleration. That change can be an increase or a decrease. So a lot of times, what you'll notice is like when we hear that word every day, like, oh, I was accelerating, or my car was accelerating, or I was accelerating at the finish line. All those things, we always think of it as just an increase in speed. But in science class, okay, it can refer to, that word acceleration can refer to an increase, a decrease, or a change in direction. So there's three examples of when something can be accelerating. Okay, so try to get that into your head, because sometimes I know it's a little bit difficult, because when we hear that word acceleration, we just think increase, but it's also going to include a decrease in speed, and a change in direction as well. So let's take a look here. Our first example of acceleration would be increasing speed. So an object that goes faster is accelerating. So that's something that we've kind of we know, and I think a lot of us know. So if we look at our picture here, we see a couple cyclists. They're on a road. They're going down a hill. So as they go down a hill, right? Anytime if you've been on a bike and you're going down the hill, you start to speed up, right? Your speed is increasing. Or if you're running down a hill, sometimes your speed is increasing. It's kind of tough to actually, when you're running down the hill, to slow down a little bit. So anytime there's an increase in speed, that's an example of acceleration. Whether you're on a bike and you're going faster, whether you're running or you're going faster, or you're in a car and it's going faster, those are examples of acceleration where there is an increase in speed. Our next one is a decrease in speed, right? Decreasing speed. A decrease in speed sometimes is called deceleration or negative acceleration. So either of those terms you can use. I think a lot of times mostly what you'll hear is deceleration. Sometimes you'll see negative acceleration. Okay, so all you would do is just kind of put a negative number or a negative sign in front of a number when you're calculating your acceleration. So this example was talking about a car slowing down and stopping at a red light. So the car is accelerating, right? Because it's slowing down, right? There's a decrease in speed. When you see, if you've been in a car and you see the red light coming up ahead of you, your car is starting to slow down, right? It's starting to decelerate. It's starting to have a negative acceleration, right? So it can stop at the red light. So that's an example of acceleration as well. Our next one, example of acceleration, is changing direction. So an object that is changing direction is also accelerating, even if it is moving at a constant speed. So for our example, a car moving around a curve or changing lanes at a constant speed is accelerating because it is changing direction. So if we look at our car, even if the car is staying at a constant speed, so it was staying at, let's say, 65 miles per hour, if it's going around that curve, it's moving around the curve, it's changing its direction, right? If it's not going completely straight, it has to follow along with the road, so it's curving, right? So it's changing its direction, right? So that means the car is accelerating even if it's staying at the same speed because it's changing direction. Another example is the Ferris wheel, right? The Ferris wheel. Many objects are continuously changing direction without changing speed. The simple example of this type of motion is circular motion or motion on a circular path. So if we take a look at the Ferris wheel, right? If you ever have gone to a carnival or a fair, you get on the Ferris wheel at the bottom, right? And then you kind of make your way all the way around, and you go around a couple times or however long they go until they stop the ride. So it's constantly changing its direction, right? So it has circular motion, right? It's going in a circular motion or circular path. So it's accelerating, right? It's changing its direction. So a Ferris wheel is an excellent example of something that's accelerating because it's changing direction. And our last kind of example that I want to talk about is the moon accelerates because it's continuously changing direction as it revolves around the Earth. So similar idea to with the Ferris wheel. The moon is going around in this model or diagram. It's going around the Earth, right, in a circular motion, and as a result, it's accelerating. The moon is accelerating as it goes around the Earth. Okay, and our last part that I want to kind of touch on was the acceleration formula, and this is something that we'll kind of get into when we're going to do some more of the math problems, kind of the math base part of it, like how we're working on speed with the distance and time. So the example or the definition of acceleration, it describes the rate at which velocity changes. So to determine the acceleration of an object moving in a straight line, you must calculate the speed, the change in speed per unit of time. So our formula for acceleration would be your final velocity or your last speed minus your initial velocity or your beginning speed, right? So initial is what you would start off with, and then you would divide by time. So it would just be final velocity minus your initial velocity or your beginning speed, and then you divide by time. And if velocity is measured in meters per second and time is metered in seconds, the unit of acceleration is meters per second, which would be written as meters per second squared. And that's really it. Make sure you guys have all your notes. This is Mr. Novak signing off. Have a great day.